Okay, so we're going to start with session 1, which is about mechanical rules and scrutineering. And I would like to start actually with hydrogen. Just a short teaser, I will fly through those first slides. Hydrogen is now the new cool stuff in Formula Student. It has been launched in 2022, basically, and already in 2023 we had a Hydrogen Concept Challenge in 3 events, which has expanded to 6 events in 2024. And now for the 2025 season we're going to have, hopefully, the first actual hydrogen cars on track. And also there will be, again, a concept challenge. Why are we going to do that? We want to propose alternative technologies because we think that, generally speaking, hydrogen will be an important topic in the future, not necessarily related to mobility. So we don't think that hydrogen will be the biggest issue in cars, but we think that promoting hydrogen to students and to new engineers is a good idea for our future. We also want to give you the possibility to build quote-unquote green vehicles without having to deal with the high voltage system, because there are actually some teams and some universities which have trouble with that. So you can go zero emission vehicle without the need for high voltage batteries. And as I said, we want to encourage students to acquire knowledge in hydrogen. We're not alone with this. There are other motorsport events which are dealing with hydrogen fuel cell and also hydrogen combustion prototypes. So we think this can generally be an exciting topic for the future of motorsports. As I said, we will again have the Hydrogen Concept Challenge. So if right now you are not yet ready to make a switch to actually hydrogen-powered vehicle, you can participate in a concept challenge. It will be basically a special award with prize money, at least for FS Austria. And it will also be a concept challenge, will also be available at other events. You can see here at the bottom we have FS Austria, FS East, Croatia, Albania, Portugal, France, and also the second event in Germany, which is going to be Formula's Future. Yeah, so as I said, in 2024 there have already been 6 events which offer the concept challenge, and in the future it will at least be 6 events as well. What does this mean now for the rule set? We don't have 2 vehicle types anymore. We have now a total of 6 vehicle types, because if you count it together with all the possibilities of hybrids that we allow, you basically can have 2 different kinds of electric vehicle, one with battery electric and also one with hydrogen fuel cell. And as you can see here, for combustion vehicles you have a total of 4 options with traditional fuels, with traditional fuel and hybrid, and with hydrogen as a fuel and with or without hybrid. And as you can see here, those 6 classes in total will be competing in the 2 standard basically classes that we know already. So the idea is to implement hydrogen as a new option within the existing classes. I want to give a short overview of what is happening with hydrogen as a fuel. Title says it already, it's not more dangerous than petrol or batteries to that effect, it's just different. So hydrogen itself is not an explosive, because an explosive material is one which has basically the oxygen within itself. Hydrogen doesn't have that, it just burns really, really well. It is the least dense gas that is, so it is 14 times lighter than air. And what that means is, if you're working or dealing with hydrogen outside, it's very low risk because at any time there is a leak, it just goes straight into the air and dissipates very quickly. And it also means that it's almost impossible, I say almost, to light anything on fire in the outside air because it will be diluted very fast. If it catches on fire, the flame is almost invisible, so that of course is a risk. You may know that from ethanol fires, which has the same issue. So if you have like nitromethanol, I think, which is the dragster fuel, if that is on fire, so if any driver has it on their driver's seat, for example, and he is on fire, it will be like this, but it will look completely crazy because nobody sees the flame actually. So yeah, that is a problem, but the jet of flame will go straight up into the air, and if you have like make sure that your system is all behind the driver and the jet of flame just goes straight up, then the driver is not actually at risk. If you're working with hydrogen on the inside, so in closed rooms, it should be noted it's a better idea to not do that at all, especially in student environments. And we basically have made the whole hydrogen rules around the fact that it's easier to just switch off the hydrogen and make it the vehicle completely hydrogen free before you go inside and into your workshops. Also, of course, the low density of the hydrogen requires high pressures. If you have like about 12 liters of hydrogen at 350 bars, which has been set as the maximum pressure limit for Formula Student at this point, it is equivalent to about 1 liter of petrol. So you will need about 40 liters of pressure tank bottle for basically a combustion car, and it will be about the same size for a fuel cell electric vehicle. So of course that is a lot of extra volume in your car. How does hydrogen work for combustion vehicles? The basic engine concept is the same, so you can basically fuel a petrol engine also with hydrogen. You can use port fuel injection. Direct injection is not really that suitable yet for hydrogen. The biggest difference is that hydrogen burns really, really fast. So if you're using the same lambda values as with petrol, so a stoichiometric volume, then it burns 10 times faster than petrol. This would normally be called knocking in a petrol engine. So in order to deal with that, you have to dilute the hydrogen with lots of air. So you need at least a lambda value of 2 or more to get it under control. In order to make it possible to have the same power, more or less, we are going to allow up to 1.6 liters or 1600 cc's of engine size. And most likely you will need forced induction coupled with water injection to get it under control, because it just burns differently. Also, of course, hydrogen and oxygen are very easy to ignite, so the ignition system doesn't really need a lot of energy anymore, but this also means it could ignite when it shouldn't really. So backfires into the intake system are really an issue and need to be addressed. For hydrogen fuel cell electric vehicles, we are currently working with a limit of 2 kilograms of hydrogen, but this is going to be up for debate. We're going to have a whole different session just dedicated to hydrogen at the very end of this event. In order to compensate for the additional weight of the fuel cell, we are going to allow up to 100 kilowatts of tractor system power instead of the 80 kilowatts it is today. And the only thing which we are stipulating is that at least 50% of the electric energy for the endurance has to come from the fuel cell. So basically a small battery, and you can drive your exploration skid pad and also autocross event with that battery. Just for the endurance, we're actually forcing you to use the fuel cell. That is the current plan in order to get it started. And now at the end of the hybrid safety part, similar to the requirements for electrical cars, so similar to the ESO requirement, we're going to have the hybrid safety officer. My colleague is just right now publishing the Slido, Slido note for that. So we are going to offer a course to participate as to get trained as a hybrid system, hydrogen of course, sorry about that. So this is about hydrogen, of course, hydrogen safety officer. We're going to have a training at 22nd of February in Karlsruhe. It will be about 100 euros per person. And you can use the link now, which is in Slido, to show that you are interested into that, so that we can finalize the organization for it. Yeah, and now I would like to transition to the main course. So hydrogen is over for now, and I would like to get started with the rules. So I'm one of the persons which are responsible for the FS rules. So I'm personally responsible for the combustion vehicle chapter of it. And I'm also, of course, in close contact with anything with regards to the technical specifications. So one of the rules which has been changed is the, I think it's in chapter A222. It's about the first year vehicle rule. Until now, it has been necessary to make significant changes to your chassis each and every year. So many teams, basically, you changed your layup, you changed your tube types, whatever, and you built a new chassis every year. Now, the new rule says you have to build a new chassis in most cases, but you can build the same chassis for multiple years. We want to make sure that, especially if you're using a monocoque chassis, that you still know how to actually laminate the car so that this skill stays within your team. So this is why we require you to manufacture a new chassis each year. But as I said, you don't have to change the layup each year anymore. And of course, this also means you can reuse your laminate test data for many years. In some cases, you can even reuse your old chassis. So this is when you're changing a powertrain type. So for example, from combustion car to electric car, you can reuse a chassis and have the same chassis for 2 years. And it is also an exception for the implementation of the autonomous system. We have made a small tweak in the definition of what is the primary structure. The anti-intrusion plate, AIP, is now also in the primary structure. It's basically a very small change. We just want to make clear, you still have to test your anti-intrusion plate according to the very specific rules which are in now T3.16. It's just to make clear that the other rules, which is 3.4 and 3.6, are going to be applied to the anti-intrusion plate as well, which according to the old rules, it technically was not. In reality, it already has been. So this rule change shouldn't really make a difference for you. It's just formality, to be honest. Rule T211, good engineering practice. This is something I want to emphasize. It is not possible to write down anything into the rules. So, for example, this is a very short rule. You have to design and manufacture your car according to good engineering practice. Yeah, okay, nice and all, but what does that mean? It means you will not pass the technical inspection at FS Austria. For example, if your primary structure, if your chassis has a very bad manufacturing quality, if everything starts delaminating, for example, in the monocoque, we just won't let you through. If you have excessive flex or just a bad load path design in safety critical components like your suspension or your steering system, we consider this to be bad engineering practice and it won't be allowed. Yeah, so the typical example is that you have a steering system, the front wheels are being held in place, and you turn the steering wheel and you can flex it for like this much and nothing happens at the wheels. This is just a bad engineering design. Similar problems can occur with the brake pedal or just generally with anything related to safety. If you are not sure, you can just write us questions at rules@fsaustria.at. But generally speaking, if you're not sure if it's good enough, probably it's not good enough. A new rule change which has been made as a consequence of issues seen this year is the rule T264. This is one of the rules which is currently being updated with the FS rules version 1.1 update, which should be published in a few days, hopefully. So the new updated version of this rule will say you need to have a 5 mm minimum clearance in the radial direction between the rim and any other static part in your suspension. So typically this is your upright and your brake caliper. The reason why we are forced to make this rule is that many teams don't have enough clearance, and when the car is moving, the whole assembly will flex. And this will lead to problems like seen here. So this is actually a carbon fiber rim. You can see here on the right, it flexed excessively and touched the brake caliper until it was so thin that the rim actually broke, as you can see here on the left. But it's not limited to carbon fiber rims. We have definitely seen a lot of aluminium rims as well, which had very lot of deep scratches, and we had to confiscate those rims. They were not allowed to participate with these rims anymore. So, but of course, this is one of the things which we understand to be bad engineering practice if you have not enough clearance. And this is just one very specific example where now there is a rule for it. But there are thousands of other examples where we consider it to be a bad engineering practice, but we cannot put it all into the rule specifically. So this is why we have an overall rule to ban bad engineering practice. And I hope you understand. General new rules with regards to the chassis. Just reiterating, most of the stuff has already been covered, of course, by my colleagues from Germany as well. If you have steel with a low yield strength below 305 megapascals, you might need to increase your wall thickness of the tubes in the future because of the way it is now calculated in the SES. There is also now extended requirements with regards to the 3D SES file. There have been clarifications and stricter requirements with regards to asymmetric layups. So asymmetric layup means one skin is much thicker than the other one. And with regards to non-isotropic laminates, which means that you have laminates where there is not a same amount of like 0, 90, plus, minus 45 degree fibers in the laminate. There is also further restrictions with regards to how you can calculate the stiffness in your SES. And there is a quote-unquote crackdown on the 3-point bending test rig compliance within the SES. But this has already been communicated like the last 5 years. So 5 years ago we started communicating to the teams, hey, your design is bad, you shouldn't use it like that. We might change it in the future, and now is finally the future. One of the rule changes, which is also just a formality basically, is we have removed the rules with regards to mechanically joining a bracing. Just to make sure these designs are still allowed, we have just removed it from the rules to save space. Yeah, there is still a general rule, which is the 3.15.1. It says any attachment point between two chassis members needs to be strong enough to carry 30 kilonewtons in any direction. These designs generally can do that. So they are still allowed, you just have to show it according to the general rule. There has been a misunderstanding, so to speak, with regards to lap belt attachments. Thank you also to Theo Bratz for pointing that out. If you have a reclined driving position like seen on the right, in most cases it will not work if your attachment point to the chassis is like here at the forward, like it is shown in the picture. You might need an attachment point which is rearwards of this seat base to seat back junction point, in order to make sure that your harness has the correct angles according to that graphic, and make sure that your lap belt actually is at the right point of the hip bones, which is also another requirement in the rules. So yeah, this is also one of the things which is currently being cleaned up for the 1.1 version of the rules, of the FS rules. Some more miscellaneous parts. There has now been made an exception for blind inserts, which many teams use to basically attach their rear plate and fix their accumulators to the car. This is currently being finalized for the 1.1 version. We have now specifically allowed any type of snap ring for snap ring design, so I have to clarify, for brake disc floaters. So in the past we said you can use it, but only a design which was off the shelf, and now it is clear you can use any kind of brake disc floaters with snap rings. A very small change in T.13, I just want to explain it. This rule means that you have to be able to safely lift and check your car with the 4 team members which have the dynamic vest. So if you need 4 members to check to actually lift the car, and you need a 5th person to put a jack underneath the car, and you have your scrutineer for help, then you're out of luck. You're not rules compliant. Me personally, I don't mind, but FS Germany is very strict about that. They don't want to put to basically help you with checking the car because they don't want to be liable for anything. So 4 persons have to be able to check out the car. And there's also been a question about this in Slido, about the fire extinguishers. Basically, there has been a process now for multiple years on how to deal with battery fires from electric cars. And we have now come to the conclusion that a foam type extinguisher in many cases is a good idea. Previously we had the powder type. Powder is completely useless for battery fires. And if you use powder to extinguish any kind of, or try to extinguish any kind of burning electrical part, you have introduced a very fine and very corrosive powder into your electronics, and they will fail in short order. With regards to foam, it's actually much less critical. Of course, yes, it is partly water, but that can be washed away and dried. Yes, then one of the most one of the biggest rule changes for 2025, it's the complete ban of ground effect devices. In the FS rules, there is a 500 watt limit. Why is it like this? Previously, we had a limit, it specifically said in the rules, active aerodynamic devices are not allowed. Then came along clever teams, and they put their radiators basically in their underground area and used completely oversized fans and said, yeah, it's not an active aerodynamic device, it's just a cooling fan. So we had to let it through. Then what we did next is, because we didn't want to argue with the teams anymore, we said, okay, let's see what happens if we just remove the ban on active aero. This was like the situation for 2 or 3 years now in the past. And let's see what happens. And what happened was that some teams, I'm not naming names, they built active power ground effect devices which were very strong, had large low voltage batteries which posed a problem on their own, and most notably they have been very, very loud. And so now we have been forced, basically we tried around with different kind of rules on how to limit it, but in the end it was no use. It wouldn't be feasible with the scrutineering resources we have to make some kind of compromise, so it's now effectively banned again. And the rule says there is a 500 watt limit on any kind of device which is moving air. Does this mean now you can build a 500 watt active aero device system? If you ask Germany, yes. If you ask me, no. We have put it into the FS Austria rulebook. The intent of this rule is clearly to ban active aerodynamics. Yeah? But we don't want to limit you on where and how you have your cooling fans. So you can have 500 watt cooling fans in your side pod. They may be designed in a way which might help you, but to be honest, with 500 watts you won't break any more skid pad records, I guess. And also specifically, in order to make sure that you don't turn up with 500 watts of siren, we have made a 160 decibel limit for these devices in the FS Austria rulebook. So if you really think that you are going to have competitive advantage with 500 watts of active aero, you can try. Not at FS Austria, you can try anywhere else. I would suggest you deal with other parts of your design, and I guess you will find more points in your overall vehicle concept there. Also, to be very sure, you have to be able to prove that your system and your fans or whatever you're using to move air is limited to 500 watts. If you don't have an off-the-shelf component with a data sheet, but you have some kind of fancy self-made design, then this might lengthen your scrutineering, your technical inspection, up to an indefinite period. Yeah? And in the end, it might be easier to just remove it or put a off-the-shelf cooling fan instead. So just be warned, fancy shit technically gets banned. Some small changes in the combustion vehicle chapter. We have now the air intake system. You have two options now basically. As before, you can attach it rigidly to your engine and make like soft rubber bushings to your chassis. Or you can do the other thing as well, which until now was banned. You can make a soft connection with a rubber hose or silicone hose to your engine and attach the air intake system rigidly to your chassis. There have been some small clarifications in regards to hybrid energy storage. So how this has to be mounted and how many holes for cooling and your harness you are allowed to put in your hybrid battery. I want to pivot now from the rules to some general tips from the mechanical side. So best practices, how to design a car. It has to be clear, in order to win a race, you just first have to finish it. Yeah? So you should really focus on anything which you should focus on small issues of a car where you can improve your performance, and you shouldn't change everything just because you can. And this might or might not be directed at the people in front of me. And you should really get your car running at least 2 months before the competition, not only because testing is very important, but also because there is a vehicle status video deadline. In order to participate at the event, you have to upload a vehicle status video which shows your car is running. And this is a very strict deadline. If you're not able to show this document, this video, you will be just dropped from the list. You have already paid your participation fee. Typically you don't get that returned. Yeah, so as soon as your car drives, doesn't matter if it has wings or not, it just needs basically the most critical driver safety systems, so like the impacted actuator, you can find the list. And as soon as it drives, just make the video. It doesn't matter if the car is pretty or not, it just needs to drive. And as soon as you're able to do it, test the car, and test the car again. This is what brings you most of the points in dynamics. With regards to your design process, I would really encourage you to use the SES template as soon as possible in your design process. Last year's template will work fine for now, because generally speaking, it won't change from year to year that much. Also, I want to make it clear here again, the FS Germany rules question tool, it is not intended for general design questions, so it's not intended, hey, I have this design, is it good or not? This tool is meant for this specific rule, I don't understand it, what does it mean, A or B? And also, off the record, so to speak, I know that many of your questions are not being answered in short order currently. So, if you want another option to ask a question, you can also contact us. Either directly if you have very specific design-related questions, you can find our contacts on the FS Austria website, or if you need an actual official rule inquiry, you can contact rules@fsaustria.at. Also some tips to make your life easier. If you use steel in your chassis, use normal steel, which is not according to the alloyed steel requirements, and make sure that it has a yield strength above 305 megapascals, because otherwise you just have to deal with additional requirements and it's easier not to. If you're welding aluminium, like in your front tube, you will also have additional requirements. It's easier not to. And also, again, if you're using laminates which are asymmetric or non-isotropic, you also have to deal with additional requirements. It's easier to have symmetrical and quasi-isotropic laminates. It's easier to do. Some tips with regards to your suspension system, so your brakes and your wheels. Please keep it conservative. I'm circling back now to your to the good engineering practice rule. A flying wheel or a disintegrating brake disc is not a good recipe for winning a race. It might save a few grams, but that doesn't really contribute to driving through the endurance. You have to consider that the parts which are rotating at your car, they are typically under very high load cycle requirements. So every time the car is doing one rotation at the wheel, this is one load cycle. So this can add up quickly and it can lead to fatigue strength, which is typically not really an issue for race cars, which is doing like 100 kilometers. Also, again, to make sure your brake pedal and also the part of the brake pedal which is used to apply the force from the shoe, this has to be metal. So the direct surface has to be metal, but left and right of it, just as a guide for your heels or your shoe. This can also be any other material. And also, just as a regular joke, it's called the brake pedal and not the brake pedal, so it shouldn't break. And we will test your brake system by applying the maximum force which a scrutineer can apply with their foot. And just be aware we have quite a lot of Schramme Wadeln in our scrutineers, so they might actually break your pedals. Yeah. Also again from last year, a short tip on how to deal with firewalls. Firewalls have to be sealed against the passage of fluids. Yeah? So you will need some kind of flange typically, and you will need some kind of seal material here in orange in order to make sure that you actually have a liquid-proof connection. And in order to make sure that the firewall itself is stiff enough, you typically need to use either some kind of sandwich plate material, which is here indicated with this kind of sandwich here, or you have to use geometric parts to make it more stiffer, for example, stiffening ribs. Also, I want to make sure again, there is a fire-resistant requirement for firewalls and also accumulators. You can test this yourself. You are allowed to do it. So if you have some kind of very special laminate which consists of 3 different materials, you will need to test it yourself because data sheets won't give all the information you need. So you just make test specimens according to the regulations. You take a Bunsen burner, you make a video of it, you put a clock in the background of the video to make sure, of course, that you didn't speed up the video, and then you bring the video and all the test samples to the technical inspection for reference. And that typically is not really a big deal, and you can use a big variety of designs for your firewalls or your accumulators. Also again, cooling systems, we do not want to restrict you with regards to your cooling fans. If you say you need more than 500 watts for cooling fans, we can talk about it. Give us feedback on it. We want your cars to be cool, to make it through the endurance. We know that there are typically very hot racing conditions at FS Austria and also, of course, in FS Arcadia. So yeah, make sure your cooling system is big enough, and if you have problems with the 500 watt fan limit, let us know. This is now my penultimate slide, and then I will go to the questions asked us. Just some more tips for mechanical inspection. We do not want to get on your nerves. We want to make sure that our competition is safe, and we want to have as many cars as possible on track. Yeah? Especially at FS Austria, we try to keep the technical inspection open for as long as necessary to get everybody through. And of course, we also have to keep it fair for everybody. So if one team has some kind of very specific design which might be an advantage, but they cannot change it, then typically speaking, we will offer them to receive penalty points, which levels the playing field, so to speak, but they can still drive. That is our way of doing it. You can prepare for the mechanical inspection by using the inspection sheet. You can find last year's example on the homepage. And also to make clear, the technical inspection is necessary for you to participate in the dynamic events. So you might not get points directly from the scrutineering, but without scrutineering, you don't get any points in dynamics. So you should treat it as important as it is. How can you prepare? As I said already, you can ask rules questions. If in doubt with your design, you should keep it conservative. Ask yourselves, does it look right? If it doesn't look right, it is a good idea to change it. You can make a dry run technical inspection with the, as I said, with the inspection sheets which are online. And if possible for you, you can participate in pre-events. And at the event itself, it is best to be prepared. So bring your documents, your data sheets, bring your test samples. And it's also a good idea to not get on the nerves of the scrutineer, because at the end, you will not have any benefit if you have spend like 3 hours arguing with the scrutineer, it will only delay your dynamic events. Okay, finally, I'm at questions now. Moderator, can you switch off my presentation now and only focus on me? So we have a lot of questions. I will sort through them shortly. One of the first questions is, the technical inspections are very different between the events. Why is that? Well, because different events have different officials which are actually organizing the event. We try, of course, to keep it consistent throughout Europe. We have more or less the same inspection sheet. We have the same rules, but every event still has the possibility to make their own version of the event, their own version of the technical inspection. That's just the part of the deal. But I can assure you, for FS Austria, we try to keep it very consistent throughout all 58 teams that we have here. Typically speaking, there are a lot of designs which are compliant with the rules, but which are made yourself. So especially in your suspension system, you might be forced to have a special design, and you have a shaft, put a thread on it yourself, and then you put your own like hole in it for a locking wire or a cotter pin. That is completely fine. If you have a very specific design and you're not sure, it might be best to actually make a rules question with your actual design in mind. Next question, please.
So apologies, I guess you didn't hear the last question on the stream, but we will still continue with the next question. So on SES calculation, should we take the thickness of the physical material before curing or the real thickness of the laminate?
You can use both. You just have to make sure that it's consistent through all types of documentation. So if you use 0.2 millimeters, you have to use 0.2 millimeters with regards to your bending tests, because this will then calculate your material values, and then the material values will be used and multiplied with the thicknesses that you put into your laminate documentation. So you can use both values, but it has to be consistent throughout the whole documentation. I think the next question is with regards to the Hans device.
No, there's one in here with how would the flex of a wing be tested for the ERS system?
So how do we test the flex of wings? Generally speaking, we use our hands. So it's of course not a calibrated system, but if you shake on it, and you typically get a good idea if it is safe for use or not. If it's not clear, we can use spring scales, so the ones which have like a hook and you can pull on them and have a scale on it. And in some cases, it's also possible to just use some kind of weight, like a 6 tray of water bottles, put it on top of the wing, and see how much it flexes. Yeah, I have one question here which is still highlighted. So it's about the head and neck restraint system, Hans device. Why is it still not mandated by the rules? We actually had a big discussion in the background with regards to the rules. we had a lot of people and a lot of teams also which wanted us to make it mandatory. We decided against it because you are allowed to use it, but we didn't want to make it mandatory because there's already lots and lots of things that you have to do. And you already have to buy new racing suits because some of the old rules are not allowed anymore. Many teams have to use, they have to buy new helmets. And we didn't want to burden you with also having to buy a new head and neck restraint system. And we have also made a worldwide survey, so we have reached out also to America especially, which kind of accidents are actually relevant for us. And a high-speed, straight-on impact into a fixed barrier, where a head and neck restraint system, which will actually help you, is very, very uncommon for Formula Student cars. So this is why we have decided against making it mandatory for us. But again, if you want to, you can use it. Yeah, and if you have the resources to do it, we even encourage you to use it, but we don't want to make it mandatory at this point.
How are you going to check the wheel rim clearance at Scrutineering?
So this is very simple, basically. You take a 5mm thick cable, so a steel cable is perfect for it, and you just pass it around on the inside of the rim. You put the front wheels into any kind of steering angle, and if necessary, we can also push the car down with a bit of weight, put the drive into the car or lift it up to make sure that the clearance is there for all kinds of ride height as well.
If the structural material in TSIC is resistant to 600 degrees but has no certificate, could we perform tests ourselves and make a video of the self-tests applied just for the firewall?
Yes, definitely. I already said it in the presentation. You can make your own tests. You just have to properly document it.
Why switch to foam-type fire extinguishers? According to our information, those are not rated for electrical fires.
We have to distinguish between a proper electrical fire, which is typically like a substation burning, or and many extinguishers say on it only suitable for electrical fires up to 1000 volts. Yeah. This is typically the case also for foam type extinguishers. As you know, we have a 600 volt limit on our cars, so you can use a foam type extinguisher to extinguish a car. And as I said already, foam is much more suitable for the broad variety of fires that we might encounter in a Formula Student car with regards, in comparison to the old powder type. And the last question?
How to understand the general name of TAB washer? This is rather a broad group of security washers, some of which, depending on the FS competition, are accepted or not. Please clarify.
A tab washer is a kind of washer where you have a part of it which can be bent in order to secure your fastener against loosening. There is multitude of design on how to do that. Mostly you just have some kind of sheet metal which has some kind of tongue which then can be folded. It's up, as I said already, every competition has their own actors which have their own mind. There is no 100% fail-safe norm, specification which is available for anybody, which says this is a tab washer and this is not. So in the end, if you're not sure, please post a rules question.
I see there are more questions coming in, so I will speed run through it. We have thermal. Oh, this is for my colleague then, and we have a 500 watt rule. Yes, the 500 watt rule again. It is of course the total power, means the combined total power of all your devices. You are not allowed to use 20 times 400 watt fans in your car. This is clearly against the rule. So any sum of your devices which move air, typically fans, the sum combined total must be below 500 watts. And because of very special questions like this, we are going to revise the wording of the version 1.1 rule. It will say combined total maximum power. I hope this is then finally clear. And the last question is about, I think, the attachment of the rear wing. Where is it now? Labels. Here. So the attachment point of your rear wing to the main hoop bracing is not allowed without additional support. I didn't have this in my presentation. But yes, there is basically within 50 millimeters of your junction point, you're allowed to put a rear wing attachment without having to use an additional bracing. Yes, that is correct. In this very specific case, please refer to the FSG Academy slides because they had it in the presentation. I did not. Yeah, so thank you very much. This is it for the first session. We will have a short 5-minute break and then my colleague will take over. Thank you very much. See you again.